So in this problem, we have a slab in the xy plane. Because of symmetry, it has a thickness of 2a, so I broke it down from 0 to a and 0 to negative a, so that is still a 2a thickness. We're given that the charge density is rho equals some rho constant times 1 minus absolute value of z over a, and we're asked to find the electric field inside and outside the slab. So I drew a Gaussian surface for inside, I drew a Gaussian surface for outside, and then we'll go through the derivation for the inside one, and that will help us out. Notice that for the outside part, when we're on the surface here, that the only charge we have is within a to minus a, so whatever result we get has to be contained inside of those. So if we look at the inside case, we can say that the electric flux is the integral of the electric field dotted with the differential element of area, but this is also equal to the enclosed charge over epsilon naught. And we have, if we look at the cylinder, we have a top region, we have a bottom region, and we have the wall region. So let's break this down into 3 pieces and say that the flux at the top is the integral of E dotted with dA, which is dA. Notice that the electric field would be pointing in this direction, and dA is also in that direction, so they're both going that way. For the wall, if we do phi E sub wall, that's going to be 0, right? Because the electric field is perpendicular to the area at that point. Again, E field is going up on the wall, dA is this way, E is that way, so 90 degrees, the dot product of perpendicular vectors results in 0, and then the electric flux on the bottom is again the same as the top. Again, if we look at it, the electric field is coming out of here, dA is coming out of here. So we can say that the total electric flux for the inside case is going to be 2 times the electric field times the area. And now if we look at a differential element of charge inside of that cylinder, we can say that it's the density times the differential element of volume, and this is rho naught times 1 minus absolute of z over a, and then the volume is going to be the area of the cylinder times the small height in it. So if we look at an area element here, that would be dA, and then dz would be this little part down there. So the charge itself is going to be the integral of dq, which is the integral from minus z to z of rho rho naught 1 minus absolute of z over a times a dz. And notice that the area is constant, z is constant, and because rho naught is constant, sorry. And because of the symmetry of the problem, we can rewrite this as rho naught a, and if I take a 2 in there, I can go from 0 to z instead of minus z to z, and all I have left in here, because z is positive in this range, would be 1 minus z over a dz. And now this is much easier to integrate because this is 2 rho naught a z minus z squared over 2a evaluated between 0 and z, which is going to equal 2 rho naught a z minus z squared over 2a. And then when we plug 0 in here, we get 0, so it's the same. So this means that phi, the electric flux, which is 2EA, is going to be the same as 2 rho naught A times Z minus Z squared over 2A. Right? This is the Qn over epsilon naught part. And now we can solve for the electric field. And I'll call it inside just to remind myself I'm solving for this quantity. The 2's cancel, the a's cancel. I forgot to put the over epsilon naught here. So I get E inside equals rho naught over epsilon naught times Z minus Z squared over 2A. And then if I want this a little more simplified, I can factor out the Z out and say this is 1 minus Z over 2A. Notice that 2A is the thickness of the slab. So if we look at the outside case, like we said, the only contributions we're going to get is when Z equals to A. Nothing else will matter. So that means that the Q inside is going to be 2 epsilon naught A times A 1 minus A over 2A. And that equals rho naught little a big A. Right, so I plugged in this in here for Q when Z equals A to get this part. And now the electric field outside is going to be Qn over 2A epsilon naught, because 2EA equals Qn over epsilon naught, so E by itself is going to be Q over epsilon naught divided by the 2A, and this is rho naught little a big A over epsilon naught A, which is rho naught A over 2 epsilon naught. And now we have the electric field inside and outside of this slab region.